So here I have a GNS3 simulator with HSRP router pair, and this HSRP router pair is interconnecting multiple clusters. So I have a cluster 1, cluster 2, and a level 2.5 cluster. Apart from this, there is a level 3 router pair as well, and this router pair is complementing the HSRP in case of link failure. So when there is no alternate path, EIGRP is going to handle the traffic and deliver it to the destination. Now let's see how the servers looks like. So I have a Windows 2019 based server, and all these servers are configured with teaming. So the NIC teaming is configured as a primary and backup. So I can verify the connectivity to the default gateway. Right, so I can reach to the default gateway from server 1. Okay, let's verify from server 2. Okay, so server 2 is 192.168.2.10, and I can ping the default gateway. Okay, likewise, let's verify the level 2.5 server. Okay, so I can ping the default gateway. Let's verify the inter-cluster communication. So from cluster 1, let's try to ping cluster 2. So I can reach the cluster 2. Okay, I can try connecting the L2.5 server, and I got the successful replies. Now let's verify the HSRP router status. So I can see all the interfaces are active on the primary router, and on my standby router all the interfaces are on standby with the default priority of 100. So on the primary I have a priority of 105. I have configured interface tracking on the cluster 1 and cluster 2 interfaces. So here E1/1, 0/1 both have interface tracking, and there is an interface tracking on E0/0 as well, which is connecting to the EIGRP router. So what this interface tracking will do is, in case of any one interface fail, so the other interface will also do a failover at the same time. Now let's try to test some failover scenarios. So from my server 1, let me start the continuous ping to server 2. Right, and while this ping is on, let's turn off the active interface E0/1. Okay, so I don't see any packet loss here, just a minor delay on the packets, and still there is a communication to the cluster 2. And as per the interface tracking, all the interfaces will do a failover to the standby except the E0/2 because there is no interface tracking on the L2.5 extension. Okay, so the EIGRP interface and the cluster 2 interface both are standby, but there is no change on the L2.5 extension interface. And let's see the status on IOU2. Right, so all the interfaces are active except the E0/2 because there is no tracking on that. So after this link is down, the traffic would be sent on this link between ESW8 and IOU2 E0/1. We can verify that using Wireshark. Right, so I can see the ICMP requests, and from the standby router, the traffic is using E1/1 to reach to the cluster 2 server. Right, so this is working as expected. Now if the link on E1/1 also goes down, so we'll try to see what happens on the second failover scenario. So I'll turn off this link, which is connecting the cluster 2, which is E1/1, and parallelly we will monitor the traffic between the clusters. Right. Okay, so I don't see any packet loss, and the traffic continues. So after we turn off this link on E1/1, uh, the link on IU1 must have gone active. So let's verify. Okay, so this is down. Okay, so E1/1 is active, and as there is an interface tracking, so the other interfaces also became active. All right, so we can find out how the traffic is being sent on the links. So from my IOU1, the cluster 1 is still using the same link because E0/1 is still active on the secondary router. So E0/1 is active, so still it's following the same path, and we can check on the Wireshark that is still the ICMP requests are being sent on this link. Okay, but the link on 1/1 is shut down. Then how the packets are reaching over here, we can find out. So there is no traffic on that link as that link is down. So from my ESW8, the traffic is reaching to IOU2, and then my EIGRP router ESW4 is complementing the alternate path, and then it's forwarding the traffic to ESW2, and then finally from the link E1/1, it's reaching to cluster 2 destination. So we can check on this link. Right, so I can see the ICMP echo requests on this link. Okay, so with the 2 links failure, still my traffic continues without any interruption. Now we can validate one more thing, that the traffic towards my L2.5 cluster, do we still have connectivity to it? So let's try to find out. Right, I can still reach to the L2.5 cluster, and let's verify from the server 2 as well. So okay, that's working fine. I can reach to my L2.5 cluster. Now let's try to find out how the traffic is being sent from cluster 1 um, to the L2.5 cluster. So let's just start a new request. Right, so we still have this E0/1 as active link, so we can expect the ICMP request being sent on this link. So my E0/2 is standby, and the usual expectation is that the traffic will not be passing on the E0/2, but here let's verify what happens to the ICMP request. So we have a unusual traffic here on the standby link. So I have checked on the Cisco references. So one of the Cisco reference says that in certain cases HSRP standby interface can send a traffic in case if it finds it as a optimal routing path. So I believe it must be checking the forwarding table, and it's identifying the 3.10 as an optimal path, and instead of blocking the traffic on the standby interface, still it is able to forward it. Uh, but we can check this on the real devices if it has the same behavior. It's not tested yet, but if the Cisco reference is right, then the same behavior uh, we can find out on the physical hardware as well. Okay, but that's not an issue here. Even if this link will not transfer any traffic, logically it should have followed the path from the complementary EIGRP, and then all the way from ESW2 it can use the active link, uh, which is connecting via L2.5 extension, and still it can route the traffic to the L2.5 server. So in both cases, we'll get the connectivity and have no packet losses. Okay, now let's see the replies. So I'm expecting replies on this link because this is the active link for my L2.5 cluster. Okay, so the link over here is sending the request, and this link over here is receiving the request. So it's a kind of asymmetric routing. Now we'll simulate the failover on L2.5 link, and let's see if we still get the connectivity. So for this, either we can continue with the other two link failed, which is already sending the traffic and there is no issue with it. So uh, let's continue the same scenario. Okay, so interface. Right, so still there is no disruption on the traffic. Okay, my active link to the L2.5 is down, but okay, but the secondary router has this link switched over as active. So now how the traffic is following the path. So now it can directly use this E0/2 for sending and receiving traffic from cluster 1 at least. So let's validate. Right, so I can see the ICMP echo requests and replies on this link. So what's the status of cluster 2? Okay, so cluster 2 E1/1 is on the primary router. So let's see if it can reach to the L2.5 server. Okay, I can reach from cluster 2 as well. So it's following the active link on the router, primary router, and then all the way from the EIGRP, it's sending the traffic to the L2.5 cluster. Okay, so let's see the link over here. Yeah, I can see the ICMP requests and the replies. Okay, so with this failover scenario, we'll try to see what if the links come back online on the cluster 1. So let's see what would be the impact. So on my cluster 1, let's keep the cluster L2.5 ping continuous on, and interface E0/1 came back online. So there is no impact on the traffic. I can still reach to the L2.5 server without any issues. So from my cluster 1, now it will follow the path from the active router, and then it can go via the EIGRP, and then finally uh, it can reach to the L2.5 cluster. So let's see from the Wireshark over here. I should be able to see the cluster 1 to L2.5 server traffic. All right. So 1.10 to the 3.10. I can see the request and the replies. Okay, now let's turn back online the cluster 2 link interface. Right, right. So no packet loss on the cluster 2 to L2.5 communication. So right now all the links are active on the primary router except the L2.5 cluster. So from my cluster 1 and cluster 2, the request will come to IOU1, but to reach the cluster 3 or the L2.5 cluster, it has to follow the path from EIGRP, and then it can reach to the server. So let's see on the Wireshark. So we can validate one by one. Let's turn off the ping on server 2, and let's see the traffic over here. Right, so I can see the ICMP echo request, but there is no replies. So it's following the asymmetric routing, so which means my requests are going from the EIGRP router, and then it's coming back on the standby link. So let's see from here. Right, so let's see if there is any traffic on this link. So we can see that the replies are coming on the standby link from E0/1. So HSRP is finding this link as an optimal point to reach to the cluster 1. So it's following the asymmetric routing where the traffic goes from the top routers, and then finally it reaches to the VM. But for coming back, it's using a different link uh, as an alternate path. So let's see if there is any impact on the TCP traffic, uh, or it can follow the asymmetric routing and it still works. So, to test the TCP, we can try with the HTTP services, which is already running on the 3.10. Okay, so I can see the web page is opening. That means the TCP traffic is through. So let's verify on the Wireshark. Okay, so from my IU2 to ESW4. Okay. Okay, so I can see the requests. Okay, the GET request, and on the other link we should be able to see the replies. Okay, so even with the asymmetric routing, the TCP traffic can work. So no issues with the asymmetric path, but this needs testing on the physical devices, right?